Hello students, yes, by the continuation of the semiconductor part in MCQ point of view, the another topic what we are going to discuss is basic or fundamental logic gates. Yes, now please see that before that we just know what is analog and digital signals. We know that analog signal means what, children? Yes, analog, and what, children? Digital signal. Digital signal. Signal doesn't mean that any new things. It may be a current or voltage. Okay. So what is yes, analog signal means between its maximum, positive and negative maximum, it can take any values. That means the values are continuous. But in case of digital signal, it is having only two discrete value. Either it may be minimum or maximum. For example, you just consider this type of yes, a signal. Okay. Either this value will be a positive maximum or 0 has to be a value. 0 has to be what, children? As value. Okay. So such type of things are called what? As a digital signal, which has the only as a two possible values, either maximum or minimum. That minimum may be 0 or any negative value. Yes. So here to understand this logic level, the maximum value of the applied voltage or current, this may be voltage or what, children? Current, this may be voltage or current. Yes. So the applied voltage or current is whose value, maximum value is taken as to be logic level 1. Logic level represented by logic level 1. That logic level 1 represents the maximum value of voltage or current, and the logic level 0. The logic level what, children? 0 represent. It doesn't mean that 0 means the voltage or current will be 0. That will be minimum. For example, if you consider, yes, if you consider the as a digital signal whose variations are given like this, yes, in this manner it is going or it is changing like this. Just to see that. So this will be the plus 5 volt, for example, and this may be the what, children? Yes, for example, minus 5 volt. Here what is the logic level 1 means? This is the logic level 1. This is the logic level 1 because the maximum value. And this is the minimum value. So this logic level what, children? 0. This is the logic level what, children? Is 0. Okay, so that is the representation of the yes, voltage or current in the digital signals by the logic state or values 1 and 0. So 1 means maximum value, 0 means yes, what, children? Minimum value. For example, in this case, this will be positive value plus this will be positive value, so logic level 1. This will be minimum value, that will be logic level 0. Not only for this case. Suppose if you consider like this, as in this manner, the voltage is changing between the negative value and the 0. It will be 0 after some time, it will be negative like this. In this case, this will be what, children? For example, minus 5 volt. This value is taken as to be what, children? Is minus 5 volt. Minus 5 volt. This is what, children? 0 volt. This is what, children? 0 volt. So here, which is the more positive value? 0 volt. Here, which is the less positive value? That means least or minimum value? Minus 5 volt. Therefore, in this case, the logic level is represented. This part has to be logic 0. This level has to be logic state 0. This level has to be logic state what, children? As 0. But this is the 0 volt. Even though it is 0 volt, it is a positive value. Therefore, it is logic level 1. It is logic level what, children? 1. So please be careful about what is the representation or meaning of logic level 1 and 0. Okay, children. So this is the basic about what is analog and digital signal. Our logic gates only functioning for this DC voltage or currents are simply called as digital signal. Signal is nothing but either voltage or current, children. Yes, this is the basic or introduction about that. Now I am going to discuss about fundamental or basic logic gates. Yes, the first one what I am going to discuss is called OR gate. What, children? This will be OR gate. Okay. So the first one what I am going to write is Boolean equation. Yes, a scientist name. So Boolean equation or expression. Boolean equation or what, children? Expression. Output y is equal to what, children? A or B. It is not like A plus B, but that is what, children? A or B. We have to read A or B like that. The second one is, yes, what, children? Yes, a logic symbol. The second one is what, children? Logic as a symbol. So what is this logic symbol means? It will be denoted. Any OR gate can be denoted like this. Yes, like this. There will be a small curve here. So this is input. A and B are inputs. Okay, A first input and B another input. And this is what, children? Yeah, is properly curved like this. Then Y is equal to ARB. Y is equal to what, children? ARB. This is the what, children? Logic symbol. There will be small curvature and with this manner. Okay. The third one is truth table. Third one is what, children? Truth table. Yes. You please see that the number of input combinations. The number of inputs are a number of input combinations, because A and B are inputs and Y is called what, children? Output. So this is output and these are inputs. Okay. So therefore, yes, that the number of inputs is equal to 2 power n, where n is number of inputs. This is number of possible input combination, number of input combinations. Input what, children? Combination, that is equal to 2 power n, where n is the number of inputs. Okay. Here how many number of inputs for our level? Yes, there are 3 input logic gates, that and all, but for our case only 2 inputs are there. Therefore 2 power 2 is what, children? Yes, so here n is equal to 2. Therefore 2 power 2 equal to what, children? 4. So therefore, yes, for 2 is input logic gate, we can get the 4 possible combinations of input voltages. 4 combinations of what, children? Input voltages. So therefore I can draw the truth table for that. So truth table is, so what, children? So this is input part and this will be output part. Okay. So input contains how many input signals? A and B, 2 input signal. Then Y is equal to ARB. Y equal to what, children? ARB. So just to follow this order, you no need to memorize. Both are 0, one is non-zero. Again I am telling that 0 means there will be minimum voltage or is what, children? Current, and 1 means there will be a maximum voltage or current. It doesn't mean that 0 volt, 1 volt. Please be careful with that. So is 0 and this is 0 and this has to be 1 and this is 1 and this is what, children? 1. Logic level 1. Yes, please be careful with this representation. 0 plus 0 is what, children? 0. That means 0 or 0. 1 plus 0 is 1. 0 plus 1 is what, children? Is 1. 1 plus 1 also what? 1. Please don't treat, because many is non-math students or non-computer students, they may think that it's 1 plus 1 has to be 2. Not like that. As maximum voltage plus maximum voltage, obviously you will get maximum voltages only. Yes, that is the meaning of this 1 1 represents and 0 represents. 0 means minimum voltage. The logic level 1 means maximum voltage. Therefore 1 plus 1 is what, children? What is the actual meaning? Maximum voltage. Maximum voltage, the voltage will be maximum. As minimum voltage plus maximum voltage, so that will be maximum voltage. In that manner you have to understand that. Okay, children. Some cases this may be stated as to be off condition. 0 means what, children? Off state. I will explain that. And 1 means on condition, off condition, on condition. Or some cases they may say that 0 has to be false and 1 has to be as a true or false. Like that, this logic level can be represented in any manner. But for our point of view, we just go with this 1 0 representation. 1 0 what, children? Representation. So these are the what, children? Possible input and output combination. Please don't memorize. I saw that many students maybe memorize this. No need to memorize anything here. You just understand it. So then what is that, children? Truth table. The next one what I am going to explain is the fourth parameter. What I am going to explain is the equivalent electrical circuit. Equivalent, what, children? Equivalent is electrical circuit. Equivalent, what, children? Electrical circuit. What these equivalent electrical circuits are means? Just consider what, children? You just consider there are the switch arrangement. The switches are like this. So these are the two switches. as which are connected to, this end is connected to some battery, as its maximum voltage is V. So that is connected with a bulb, a electrical bulb or LED, yes, whatever may be that. Yes. Now please see that, as this is like input A and this is like input B. When A and B are open, that is called open means what, children? There is no voltage across this point. That is called zero voltage, or doesn't, yes, here it will be zero voltage. That means what is that? Logic level 0. Please understand, children, logic level 0 means it doesn't mean that 0 voltage. Logic level 1 means it doesn't mean that 1 volt. Logic level 1 means there is a maximum voltage. Logic level 0 means there will be a minimum voltage. That minimum voltage may be a positive value or negative value, as I explained here. Okay, children, please be careful with that. So the first case is what? Both the inputs are 0. Yes, that means both the switches are open. Then obviously we know that there is no current flow in the circuit. So bulb will not glow. That means it will not emit any light. Okay, so there is no emission of light. That is called what, children? Off condition. That is called what condition? Off. The bulb is switched off, like that we are telling, no, off condition or zero logic state. Suppose A has to be 1, B has to be 0. Suppose this will be closed, as this will be closed and B is open. Now what will happen, children? So the current will flow through this part of the circuit. Now bulb will glow. It can emit the light. It can, what, children? Emit the light. That is called what, children? On state, or we can say that is what, children? As a maximum voltage condition. That is logic level 1. Similarly, what? A has to be open and B is closed now. B is closed now. Then again bulb will glow. That means on state or logic level 1. When both the bulbs are switches are connected like this, that is 1 1, the bulb will glow or on state. That's why it is called logic level 1. So this is the very simple understanding about the electrical circuit to understand the OR gate logic operation. The another one is construction of OR gate using diodes. Construction of OR gates using what, children? Diode. Yes. Sometimes the circuit may be given, but it's easy to understand. We know that the simple logic, what you must remember is forward bias for ideal diode. For what, children? Ideal diode. As a forward bias means its input resistance will be 0. That is, it just like a connecting wire. Just like what, children? Connecting wire. Connecting wire means the resistance will be 0 or negligible. If the diode is, that means forward bias, in forward bias Rin is 0, therefore diode conducts. Diode conduct the current. Diode conduct the current. In reverse bias, what will happen, children? In reverse bias mode, we know that this will be considered to be RF, forward bias resistance. This will be R small r, reverse bias, what is that resistance? It will be very high, or we can consider that the diode will act as a open circuit. Diode will act as a open circuit, and this will act as a what, children? Connecting wire or closed circuit. Connecting wire has to be our closed circuit. So obviously we know that when the diode is acting as a open circuit, there is no current flow. There is no what, children? As a current flow. There is no current flow. Yes. So this is the basic things what we must keep in mind. So now I am going to construct a OR gate by using what is that, children? As the 2 junction diode. Yes. It is considered this is a junction diode D1, and this is the another junction diode, what, children? As D2, which are connected to a power supply. Which are connected to what, children? A power supply whose voltage is V, and this is like this. This is ground. Yes, we know that ground symbol. Yes, ground. This is voltage V, and what, children? Yes, there is a connection between them, and this is the resistance R, and which is grounded, and this is your output terminal. Y is equal to ARB. Y equal to what, children? ARP. Yes. Now please see that in this situation, I can explain the same thing in this manner. I will explain one or two logic inputs, then you can understand for the remaining part also. If A and B are 0 means these are the input terminals A and B. Okay. So when A and B are 0 means they are not connected with the batteries. They are not what, children? Connected with the battery. If they are not connected with the battery means this terminal is at what, children? 0 voltage or logic level 0, minimum voltage. 0 voltage or what, children? Minimum voltage. Therefore this is ground. This will be ground. So we know that in this case, since the inputs are not given, as there is no flow of current. There is no what, children? Flow of current, because there is no supply itself. So because of that, there is no flow of current means there is no potential drop across this point. Therefore output has to be 0. So that is the part, output has to be 0. Suppose now we consider the diode 1 is maintained at the forward bias condition. That is, it is connected with the battery, it is not connected with the battery. Suppose you assume that it is not connected with the battery. Now this diode is in what, children? Forward bias, and this will be in what, children? Reverse bias mode. That will be in what, children? Reverse bias mode. So in that condition, reverse bias mode, what means this will act as a open circuit and this will act as a closed circuit. Okay, so under the reverse bias mode, for this logic condition, this will act as a open circuit and this will act as a closed circuit. Therefore the equivalent circuit can be drawn like this. So this is say some voltage value, say for example some plus 5 voltage, something like that. Then this terminal A, so the terminal A is at what potential, children? Plus 5 volt. Now this diode is in forward bias, which will act just like a connecting wire or closed circuit. So that will be directly connected. This D1 is replaced by just like a connecting wire, and this part, since this is in not connected to any for biasing voltage, therefore this is under reverse bias, which will act as a open circuit. Therefore since B is 0 volt, we are not given any voltage, therefore diode will act as a, D2 will act as a open circuit. D2 will act as what, children? Open circuit. So that will be there, and it is connected to a resistance like this. Yes, this is the resistance. Since we know that in current electricity, you may study that concept of same potential in the electrical resistance circuit. Whenever a wire is connected, then all the points are having same, what is that, potential value, since the conducting wire will act as a equipotential surface. Therefore here also 5 volt, here also 5 volt, here also what, children? 5 volt. This is our output terminal Y. This is our what, children? Output terminal Y. So therefore here also 5 volt, since the diode will act just like a connecting wire or a closed circuit. In a connecting wire, all the points are having same potential. Therefore at this point also voltage is what, children? 5 volt. That means the output terminal is having maximum voltage. Maximum voltage means that is corresponding to what, children? Logic level 1. That is corresponding to what, children? Logic level 1. Yes. Similarly for the remaining combinations, in the same manner you can explain. You can understand that. For example, yes, now this is maintained as what is that, open is not connected with the battery, that is A is 0. It is connected with the battery, that is B is equal to 1. Now what will happen, children? This will act as a open circuit since it is under reverse bias, and this diode will act as a forward bias and just like act as a connecting wire. In the same manner, this part will be open and this will be closed, and here 5 volt means the same wire we having the same potential. So here also that what, children? 5 volt. In the same manner for this 1 volts, both the inputs are high. That case also we can easily understand, children. Yes, I hope that you can get the clear information about OR gate and its construction using what, children? Yes, so here I can draw that it's a very general circuit. Very general circuit. I can say this has to be as input V and this has to be input V. But in order to explain the working of this circuit based on different logic levels, you just rearrange the circuit as we explained as now. Yes, please note it down, students. Another second gate for the basic logic gate is AND gate. I am going little bit fast since I gave the introduction. What are the things we have to be discussed in the case of diode, logic gates. So now please see that the first one is a symbol. I can write that this is the logic symbol for AND gate. This is the flat one. Previously, that will be a curved one. That is the difference. So this is output Boolean equation. A and B, the product is A and B, yes, A and B, like that you have to, yes, ready. The Boolean equation there itself I wrote. Now the next one is a truth table. Next one is what, children? Yes, a truth table. Since it is a 2 input logic gates, as we said, 4 combinations are possible. So this is the input part and this is what, children? Output part. This is input 1, this is input B. A second input, that is y is equal to output, y is equal to A and B. Yes, we know that. So 0 0 1 0 is 0 1 and another one is what, children? 1 1. Yes, 0 into 0, that means lower voltage or minimum voltage is minimum only. Minimum means off state or logic level 0. 1 into 0, obviously that will be 0 only. 0 into 1 is 0. 1 into 1, what, children? 1 itself, that is logic level 1 or maximum voltage. So this is the truth table for AND gate. The corresponding electrical circuit. Corresponding what, children? Electrical circuit. What is this electrical circuit for this case is, just consider the situation in this manner. Yes, so this is the circuit, equivalent electrical circuit consider. So you just see that when A is open, B is open and there is no flow of current, so bulb will not glow. Glow means off state, that is logic level 0. A is closed but B is open, even there is no flow of current, off state. When A is open and B is closed, there also no flow of current, then off state. When A and B are connected together, then there is a flow of current, that is called on state 1. Yes, so this is the explanation for equivalent electrical circuit. The fourth one, what we are going to tell, that one is what, children? Is construction of AND gate using what, children? Is diodes. The same property as we discussed in the OR gate explanation using diodes. Just see that in this case the diode will be connected in this manner. So yes, this is the diode D1, this is diode D2, this is a terminal input point 1 and input point 2 and they are connected with what, children? Is some power supply. So power supply positive voltage, say for example plus 5 volt, like that. Some resistance R will be there, since large current will damage the diode. So this is the your output point Y equal to A and B. Yes, children, as I said, when A0, B0, when A0, B0, that means these terminals are at the lower potential when compared to this plus 5 volt, that is maximum voltage. So this is what, this P side of the junction diode is maximum voltage and the N side of the junction diode is minimum voltage. That means maximum voltage, minimum voltage. That when we can say that this diode is in forward bias. Similarly, this also not connected to any power supply. That's why we are telling that logic level 0 0. Therefore, this is 0 or lower potential. This will be connected to the maximum potential. So minimum potential, maximum potential. So this diode also in forward bias. Forward bias means what, children? This will act just like a connecting wire. This will act just like a connecting wire. So therefore, all the current will passing through the diode. All the currents will passing through the diode and go to the ground or negative terminal of the battery. Negative terminal of the what, children? Battery. So therefore, all the currents will passing through this diode itself. Therefore, there is no voltage, because you just see that if A is equal to 0, B is equal to 0. In that condition, what we said, both the diodes are in forward bias. Therefore, this is A and this diode will act as a connecting wire. This diode will act as a connecting wire D1. This also connected as a connecting wire D2. Yes. Since we said that this A and B are maintained, for example, at 0 voltage, then they are in the minimum voltage, maximum voltage point. Forward bias, minimum voltage, maximum voltage, forward bias. So they will act as a what children? As a connecting wire. So this is 0 volt for example. In a connecting wire, we know that in a connecting wire, we know that yes, this is output point Y. In the connecting wire, all the points are having same potential. So 0 volt, 0 volt, 0 volt. Here also what children? 0 volt. Therefore Y, at the point Y, we will get only 0 volt. That is minimum voltage. That is considered to be as what children? Logic level 0. Similarly, you just explain or you can understand for logic level 10 cases. 10 cases means what children? The first diode is now connected to 0 voltage and this may be connected to plus 5 voltage. That's why the logic level 1 is there. So for example, A is equal to 1 and B is equal to 0. For this case, how to understand the parts are means, just said that A equal to 1 means it is connected to plus 5 voltage. Therefore, as you just see that children, so this is connected, A is connected to, for example, plus 5 volt. Similarly, this end also, yes, what children are, this end also 5 volt as we shown here. Yes, what will happen children? Here also maximum voltage 5, here also maximum voltage 5. That means there is no a forward bias. So this diode will act as a open circuit. But the second diode is what children? Not connected to as any battery or what is that as a supply voltage, or we can say that this is at what children? 0 volt. So lower potential, higher potential 5 volt here. So higher potential, lower potential, forward bias. So D1 act as a open circuit and D2 will act as a closed circuit. Therefore, the equivalent electronic circuit can be drawn as to be like this. Yes children, now you please see that. Yes, A and this diode will act as a open part and this will act as a closed one. So this diode will, D2 will act as a closed one because this is under as a forward bias and this is under what children? Reverse bias. So this is connected to, for example, 0 volt. Therefore, the point B is at 0 volt. So 0 volt means what children? This is just like a connecting wire. All the points are having 0 volt. All the points are having what children? Is 0 volt here. So 0 volt, 0 volt, 0 volt, 0 volt here also. So therefore output has to be what children? 0. So that is the explanation for 10 case. In the same manner, you can explain for 0, 1 and 1, 1 case. If you are consider the 1, 1 case, that means both the as diodes are connected to 5 volt to 5 volt. So here also 5 volt to 5 volt will be there. Therefore, they are in, both the diodes are in reverse bias. Therefore, both the diodes will consider to be a open circuit. See, if both the diodes are open circuit means, for example, A is equal to 1, yes, B is equal to 1. When both the diodes are open circuit, then what will happen children? Yes, there is no flow of current. There is no what children? Flow of current in the, yes, across the or through the diode. Yes, it will be like this. So R plus 5 volt and this is a terminal Y. So these are terminal A and B which are connected to plus 5 volt like that. So they are open circuit. So you just see that there is no flow of current across this. We know that when there is no flow of current through the resistor, both the points should have the same potential similar to our as Wheatstone bridge balance condition. Therefore, this is plus 5 volt means this point also plus 5 volt. Therefore, output is having higher voltage or logic level 1. Higher voltage or logic level what children? 1. That is nothing but here is a 5 volt value. Logic level 1 or what children? 5 volt 1. Yes. So I explained 3 output. You can do it for or explain for, understand for this logic level also. Yes. This is the explanation about what children? Yeah, another basic logic gate and gate and its circuit arrangements and working. Yes, please kindly note down the students. Please see that the last one for the basic or fundamental logic gate, that is NOT gate or inverter gate. NOT gate, or simply we call it as what, children? Inverter. Yes. Just see that. Yes. What is that complement or bar? Yes, a complement or the word bar. Yes, we can say that. For example, A has to be 1. Then we can say that A bar, A complement means we have to reverse the value. If it is maximum, then the opposite of that will be minimum. That is A bar value has to be 0. So when A equal to 0, the corresponding complement that is written has to be A bar, that is minimum means there will be maximum. Yes, logic level 1. That is the meaning for the word complement or as bar over the as input. Okay. Now please see that NOT gate symbol is what, children? Symbol is a single input gate. Sorry, logic gate. Yes. So it will denote it like this. So this is input and Y is equal to A bar. So whatever the input given, that will be reversed. That's why it is called a inverter. Yes. Truth table. What, children? As a truth table. Now please see that. In this case, we can write the truth table as this will be input and this will be output. Yes, so A and this Y is equal to A bar. So 0 means 1, 1 means what, children? 0. That means minimum voltage means maximum output voltage, maximum input voltage means minimum output voltage. Like that you have to understand. Yes, the corresponding is what, children? Is how to design or construct the NOT gate. That can be constructed by using a transistor. For example, you consider a NPN transistor. You just consider what, children? A NPN transistor which is connected like this. So this is the input part, that is base. This is RB and this is what, children? RC, which is connected to some plus 5 voltage or VCC. Or we can simply say that that has to be VCC. Okay. Yes. Now please see that in this case, as this is connected to ground, this is connected to ground, and this is my what, children? Output point. Y is equal to A bar. Y is equal to what, children? A bar. So this is the input terminal A. If I am maintaining as input has to be 0, that means no input voltage is given here. We know that we are already studied in what is that transistor characteristics. When VB is 0, so A is 0 means what, children? The VB value, base voltage, the input voltage for base will be 0. When VB, input voltage is 0, the input current IB also 0. Input current IB also what, children? 0. When input current IB is 0, we just see that in the transistor equation just now is discussed in the video lectures. So therefore, as the output voltage is what, children? As V out, that is equal to as or we can say that is VCC, that is equal to IC RC plus what, children? As VCE. This is the thing what we discussed. The applied voltage equal to sum of the voltage across the remaining part. So this is the emitter, base, and this will be what, children? Collector. Yes. So when input voltage is 0 at the base end, that means input A is logic level 0. Input A is what, children? Logic level 0. There is no base current. If there is no base current, there is no what, children? Collector current also. As we said, it's very negligible, but it can be considered to be 0. Then VCC equal to VCE. That means the output voltage will be maximum as that of the applied voltage. Therefore, when the input has to be 0, input has to be 0 logic level, then we can get that output has to be logic level 1. That means maximum voltage. So in this condition, that is called what we said, children, is cutoff region. What we said, children? Cutoff region. Suppose if we consider the input point is maintained at as a higher voltage, that is if logic level 1. If higher voltage means logic level 1. So you are applying the maximum input voltage to the base layer. When input is maximum, VB is more, IB also more. IB also more means what, children? IC also more, and this condition will takes the transistor to the saturation condition. transistor to the what children? Saturation condition. So under this condition, is y equal to 0. Under these input conditions, the transistor is at what children? Saturation. Transistor is at what children? Saturation condition. Under this saturation condition, we know that the graph we are studied that this is V in and this is V out. As for transistor case, we are studied like this, and this is cutoff region. This is what children? Is a cutoff region. That is this case number 1. For the logic level, as a logic state 0, the corresponding maximum output voltage will be there. Maximum output voltage as 1. So when this region has to be, yes, what children? Saturation. This is what children? Saturation condition. So under this condition, what will happen? The output voltage becomes to minimum or approximately 0. Therefore, for this case, the transistor is taken to the saturation condition. So there is no as output voltage across this collector terminal. That's why it is y equal to 0 children. So this is the explanation for all the basic gates. So far we discussed OR and NOT gate. Yes, please kindly note it down, students.